In 2024 there will be a once-in-a-lifetime stellar explosion visible from everywhere in the constellation Corona Borealis. There is a very special star called T Coronii Borealis, better known by its acronym TCRB. This star is actually a binary system containing two stars that are very different. But what's so special about this binary star? Recently a group of scientists from Louisiana State University published a study on this star in the Journal for the History of Astronomy. In that article they explained that this star could be about to experience a colossal explosion known as nova in 2024. But what is a nova and how do we know precisely when it will happen? Stay with us to find out. T Coronii Borealis TCRB is a 10th magnitude binary star, meaning it is not visible to the human eye and is barely visible to amateur telescopes. TCRB is not a single star but a star system of two different stars. Most of the stars in our galaxy are of this type. There are theories that billions of years ago the Sun may have had a companion, and both the Sun and its companion orbited around a common center of mass. This theory is still open in the scientific community, and many astronomers consider the possibility that the Sun had a companion in its past very likely. Binary stars are exciting in scientific research because each star that makes up the system can influence the other differently. The stars in a double star system are usually called components, and each component has different characteristics. The binary system TCRB comprises a red giant star and a white dwarf star. The system's two components orbit around a common center of mass every 228 days with an orbit that is nearly circular and tilted at an angle of 67 degrees. The two stars are known to be extremely close, separated by only 0.54 astronomical units less than the distance from Venus to the Sun. In other words, the two stars are so close that the gravitational effects of one influence the other. The biggest star in the system is a red giant in its last stage of life before becoming a white dwarf. The hottest component is a white dwarf surrounded by an accretion disk. This accretion disk is the factor that produces novae, but how exactly are they produced? A nova is a transient astronomical event that causes the sudden appearance of a bright, apparently new star. Hence its name nova, which in Latin means new. This appearance of a new star is temporary and can last for weeks or months. However, it is not the appearance of a new star, but rather a phenomenon that unleashes brightness, giving the impression that a new star appeared when viewed from Earth. A nova forms from two main sequence stars in a binary system. Normally the stars in a binary system are very similar. However, most of the time one of the two stars will have a greater mass than the other, so the more massive star will consume its fuel faster and reach its final stage of life sooner. When one of the two stars evolves into a red giant, it begins to die, ejecting its outer layers and scattering all the materials it formed during its lifetime into a planetary nebula. When the star has ejected all its outer layers, only its core remains, known as a white dwarf. Although they seem small and cold, white dwarfs still retain a large amount of mass comparable to that of the Sun, while their volume is comparable to that of Earth. This new white dwarf is still gravitationally anchored to its companion, which has not yet reached its last stage of life, and both continue to orbit around a common center of mass. When the second star reaches its last stage of life, it undergoes a process similar to the first becoming a red giant, and then gradually freeing itself from its outermost layers composed mainly of hydrogen. At this stage something extraordinary happens. The outer layers released by the second star begin to be absorbed by its companion, the white dwarf. As a result, the white dwarf captures matter from its companion's outer atmosphere and begins to form a hydrogen accretion disk around it. Since the white dwarf is made of degenerate matter, hydrogen does not inflate. Instead, its temperature increases significantly, becoming ionized hydrogen. Hydrogen fusion can occur stably on the surface of the white dwarf, resulting in a supersmooth X-ray source. However, hydrogen combustion is usually thermally unstable and quickly converts into heavier chemical elements. This creation of elements from hydrogen causes an exothermic reaction that releases enormous energy, ejecting the remaining gases from the white dwarf's surface and producing a bright light in an explosion. This burst is what we call a nova, a drastic increase in a star's luminosity. This brightness increase can be remarkably rapid or gradual, and after the burst of light occurs, the brightness decreases until the star returns to its average brightness. The time it takes for a nova to decay by about 2 or 3 magnitudes from maximum optical brightness varies depending on the size of the star. Fast novae will normally take less than 25 days to decay by 2 magnitudes, while slow novae will take more than 80 days. T Coronii Borealis TCRB is classified as a recurrent nova because it has had different novae with a certain periodicity since it began to be observed. Before moving on, be sure to like or dislike the video so that we can improve for you the viewer. Plus don't forget to subscribe to our channel and hit the notification bell so you don't miss any of our daily videos. How do we know it will explode in 2024? TCRB has had explosions in the past recorded by the American Association of Variable Star Observers AAVSO. The first occurred on May 12, 1866 and the second on February 9, 1946. Both events were TCRB explosions that reached a magnitude of 2 bright enough to be observed with the naked eye. Astronomers discovered that before the star's luminosity increases, it decreases slightly. Scientist Justin D. Linford of West Virginia University analyzed the star's activity between 2015 and 2016 and found that during this period the star became much brighter than usual and expelled a significant amount of X-rays. The scientists collected information from different radio telescopes and telescopes, creating a model of the star's behavior. They concluded that the star's current behavior is very similar to what was observed in the 1940s when the last explosion occurred. To corroborate this, they compared data from 1938 revealing evident similarities. The behavior of the star during 2015 and 2016 closely resembled how it behaved in 1938, 8 years before the 1946 nova. According to current records, this corroborates existing information about past TCRB explosions. In 1945, a year before the 1946 explosion, astronomers noted that the star's total brightness decreased by 2 orders of magnitude from 10 to 12. Remember that in astronomy a higher magnitude indicates a fainter brightness, making it more difficult to see. The maximum magnitude visible to the human eye is approximately 6 or 7. Beyond that, visibility diminishes. Thus TCRB is challenging to observe without special telescopes or binoculars. Returning to the main point, just 1 year after TCRB dimmed its brightness, an explosion occurred that was visible from Earth as a nova. This explosion increased TCRB's brightness to a magnitude of 2, making it visible to the naked eye. On May 11, 1866, astronomer John Birmingham observed this star for the first time when it suddenly appeared in the sky. At that moment, Birmingham was unaware that this star had not just appeared, he had discovered a nova. It is believed that the star likely dimmed its brightness slightly the day before Birmingham's discovery, leading to the explosion. In summary, we observe a repeating pattern before the star explodes as a nova. First, TCRB decreases its brightness for about a year, then returns to its initial brightness, followed by another decrease after 7 years lasting for a few months. Finally, a year after the last dimming period, it explodes in a nova, increasing in magnitude up to 8 times, becoming visible to the naked eye. Observations indicate that last year, 2023, TCRB experienced a decrease in brightness just 7 years after the last dimming in 2016. This suggests that TCRB will undoubtedly explode again in 2024, producing a nova visible to the naked eye. How and where to observe it? At Insane Curiosity, we strive to be honest. This event won't repeat for another 80 years. Unlike the solar eclipse of April 8, this nova won't be easily seen. Remember that TCRB is a 10th magnitude star not visible to the naked eye, making it difficult to find unless you have experience with telescopes. We also don't know the exact date of the explosion. It's thought to occur between April and September of this year, giving a several-month window. When it happens, you should look for a star of magnitude 2 in the sky. While magnitude 2 stars are not incredibly bright, they can be found if you know where to look. TCRB is located in the constellation Corona Borealis, just below the corona on the left side of the star Alphecca. On a typical night, you can see Corona Borealis as a small semicircular arc between the constellations Boötes and Hercules. This is where the TCRB burst will appear as a new bright star, going from a magnitude of +10 to +2, similar in brightness to the North Star Polaris. Once its brightness peaks, it should be visible to the naked eye for several days before dimming again, possibly for another 80 years. Finally, keep in mind that this star is approximately 3,000 light-years from Earth. The light we see from TCRB has taken 3,000 years to reach us, meaning we won't know everything happening with that star right now until the year 5024. In essence, the nova we will observe this year already happened 3,000 years ago. The light from that event will arrive only this year. Now we want your opinion on what date do you think the TCRB nova will occur. Write your prediction in the comments.